All right, now let's implement this in our own system. Create a folder for this. Okay. All right, we use Nano. So Nano is a really nice tool for editing in terminal. Nano mnist tf.py. Let's start copy pasting this codes. So first this item import number is np tensorflow from tensorflow import keras, and then again from tensorflow keras import layers. All right, now prepare data, so shape, loading data, normalizing data, expand dimension to match the input dimension, and one-hot encoding of input data. So there is other option also other than one-hot encoding. Without one-hot encoding, we can keep the numbers as it is. We just have to change this categorical cross entropy to sparse categorical cross entropy. So it will calculate that one-hot encoding and all will be taken care internally. We don't have to explicitly do one-hot encoding. I think that will be a better practice. But for now, let me first just copy paste and just run this once. Now building data, the sacred part. So say a simple model, control D, and then take this. And finally, our training, the heavy lifting, model compile, loss, categorical cross entropy, optimize algorithm, matrix, and then finally our model fit. Yeah, let's take the evaluation also. So here as well we are evaluating the model, or basically testing, we can say, on tests data set. All right, so this we can say as a minimal code. Okay, here one major part is this loading data. We will see that in the later sessions, how to practically when we have a set of images in our folder, how to use that data, how to load that data, that we will come to know. So here one thing I have to tell you, here we are loading the x train, y train, x test, y test into memory directly. So there is no data generator involved. So we will come to, we will learn about data generator later. So this is loading the entire data into RAM, into memory, and then training. So if possible, go for loading into memory always. And if the data is too large, then we can't do that. We will run out of memory. In that case, we have to go for data generator, which we will learn afterwards. Okay, Control X, save yes, and enter. So here's our code, and now we will just run this and see. Okay, just we'll open it in VS Code also. So with a code editor, it's much better. You can see all the colors and easy to read. But if you are working on quickly want to create a file and just add something, this is a good option. All right. Yeah, okay, let's run this and see. So Python mnist tensorflow.py. If you are running this for very first time, it will take some time to load this data. Second time anyway, that will be cached. So it is sitting somewhere where this Keras is installed, and so it will be cached there. So next time when you run, it will just take the data from there. All right, this might take some time. Okay, we can see here this data is downloaded. And here is the model summary, and there we go. The training has started. Increase the size a little bit. It will come in one line, otherwise it will come like this. So accuracy already reached 98, almost 99, and we can see the loss value reduced from higher value to 0.5, 0.4, 0.04, 0.03. Here again, keep on reducing. And test accuracy 99, test loss 0.02. Here training loss was 0.03, and this is 0.02, means a nearby. So it's a really good sign that on training set it was able to learn well, and then on test set it is showing similar loss, which means it that's a really good trend. If this loss is low and this is high, means it has started overfitting already. So here instead it is even lower, means it's really good situation. It's not it haven't gone into any overfitting or anything. And test accuracy is also really great, and near to train accuracy, or here a little bit more than train accuracy. This is a really good situation. And the main reason for getting this much good accuracy is low input dimension, 28 by 28, and there is no other background information, like it's just a grayscale or black and white kind of grayscale image, one channel image, and that low dimensionality is one key thing for getting good accuracy. But in practice, we can't always go for that much low dimension. So as much as possible, always choose low dimension whenever possible. That will help in increasing accuracy, as well as clean data. In this data set, it is having all kinds of numbers, but it is clean. Like a number 5 is not there in class 2, and but in practice, often that cleaning, there will be limitation in how much clean data it will be. That also causes is the reason why in practice we won't be getting this much accuracy every time. But if we really put effort, it is possible, and that's what this mnist is proving. Okay, so that's our TensorFlow example. Next we can check our PyTorch example.